This is Coda Radio, episode 366, recorded on July 8th, 2019. Hello and welcome to Coda Radio, Jupiter Broadcasting's weekly talk show that takes a pragmatic look at the art and business of software development and related technologies. My name is Wes, and I'm glad to be joined the explorer on the functional final frontier, Mr. Michael Dominic. Hey, Mike.
Hello, Wes. We are all functioning on this very special episode of Coda Radio.
Yeah, that's right. So to be out in the open about it, this is a pre-recorded episode. We're both away, but we didn't want to leave you high and dry with no Coda Radio to listen to. Of course not. So we thought now is a good time. Mike brought this topic up. It's obviously something near and dear to my heart. We talk about functional programming all the darn time. Maybe we could actually take some time, talk basics, and maybe a little bit about, using it in the gosh darn real world. What do you think, Mike?
I love it.
Okay. Well, before we dive into that rather heady topic, I thought, this is Coda Radio. We haven't talked about WebAssembly in what feels like months, and I noticed a little story. I'm curious to see what you think about it. Some people over at Fluence have been working on a port of Redis to WebAssembly.
Yeah, so I guess it's true. Everything that we can put in WebAssembly, we're going to. Kidding aside, actually, this is pretty neat, because now you can run Redis basically anywhere WebAssembly runs, which, depending on when you're listening to the show, might in fact be everywhere. I think this is cool. I think more things like Redis, like foundational things that you use to build other solutions, that can be ported to WebAssembly as an option, not maybe as a mandatory thing just yet. I think that's going to, frankly, just open up a lot of opportunities for people. How about you? Yeah,
right. I mean, if you're already familiar with Redis, you can use it, and you're able to just sort of port some of that know-how and methodology and use it in the browser, or as a on some random thing that's had a WebAssembly environment ported to it. That is pretty handy. And I think Redis is kind of a good mix. It's not crazy complicated, single-threaded, but also super useful. It's a nice abstraction. Many people use it. And if you go take a look at the article, which I encourage you guys to do, it's a good breakdown of sort of like where this tech is at and some of the problems you might run into and why it's not, it's not necessarily the perfect solution or something you might even want to use, but it's a nice way to see how this stuff is all evolving. Because it takes a lot to get something actually running as a complicated existing application actually running in WebAssembly. Do you use much Redis yourself, Mr. Dominic, since we're talking about the subject?
You can use it quite a bit in Rails, and I have. I mean, ironically, I would probably not use it in WebAssembly, but yeah, I've used it in conjunction with Rails projects.
Well, I imagine this trend will continue. We'll keep seeing more and more things ported to WebAssembly. Have you had a chance to play with it anymore?
Honestly, I have not. I take it back, actually. When I did what is it? Oh my God, the Realm ML language you had me do.
Oh, Reason ML, yeah.
Reason ML. That had a WebAssembly capability, and I did play with that some.
That's an interesting point too, right? We're seeing more as newer languages develop. I imagine WebAssembly might just be a runtime they're already thinking about.
It's going to be the one true runtime, I bet.
I would like to play a little bit more on the back end with just running it sort of on the command line and away from a browser. I've only ever played with it in a browser so far, and not enough to do anything useful, I'm afraid. Definitely something we're going to continue to watch. Now, Mike, you came to me with the topic for today's show, and you had an interesting idea for the approach. And I'm kind of just curious, as we get started, where are you on your journey of exploring functional programming?
So I'm basically a convert. I've been exploring it for a while. I've been more and more bought into it. In fact, I'm writing a post. I've been writing it for weeks. I haven't finished it. Titled "F# is your functional gateway drug," and I'll be damned if it isn't. It's been pretty interesting. I think we're going to dive into this a lot, but the thing that really drew me to FP was solving, I'm going to use a technical term here, the gobbledygook spaghetti code problem that you tend to get with traditional OO patterns.
Absolutely.
Yeah, gobbledygook. You can look that up or call someone from MIT. They'll explain it to you. And I have to say, I am more and more, and I've looked at this for a long time, but I am now basically trying to be functional first, which is a big change.
So looking at that as the paradigm that you try to express a problem in, rather than defaulting to using an object-oriented approach.
Exactly. So where I can find a functional pattern that works, where I can do something with either no state or at least immutable state, that is what I'm doing first. No, that's not to say I'm not still using a bunch of OO, right? Of course I am. I read a lot of Ruby, a lot of Rails. But I really am, like, I'm trying to not have, like, magical singleton classes that have a bunch of state and do a lot of stuff, right?
That's a good clarification. And, that's another thing I think we should talk about is, it's all well and good, right? I've assigned you to use Clojure for a week or two, and you've been playing with F#. Well, there's lots of almost mainstream functional languages these days, especially if you include some of the modern features .NET and Java have. All that means you can do functional programming. You can apply functional programming techniques or design philosophies or patterns in a lot of the languages that you use. I imagine this means you've kind of had to teach, if you've converted, you've had to start teaching those around you too, right?
A little bit, yeah. I mean, some of the languages make it easier than others to kind of bring people in. So C# in particular, particularly version 6 and 7, and I think the current one is 8, but we're mostly using 7, has adopted a lot of some of the patterns from F#, and they're optional, right? You don't have to do it, but you certainly can. Other languages, I think, are a little harder to be kind of functional with, particularly Ruby. Impossible, and there's definitely, like, trivial things are obviously easy because they're trivial. But
of course.
But, like, just active record, right? When I say Ruby, I really mean Rails. Active record, and just the whole thing is designed to be OO. Swift is actually really nice if you try to look at it from a protocol/functional or programming orientation. I mean, so far I think C# has actually added of the languages I use routinely, added the kind of the easiest transition. But then you know what happens. You're using C# and you're just like, oh, but I could be in F# right now. That might just be me.
No, of course. Once you've sort of had a taste of it, you want more.
Right. Now where do these languages stack up against, obviously, the one true language, Clojure?
I mean, I don't know if you should call it that. We shouldn't forget things like Haskell and Idris on the spectrum, right?
So maybe this is actually a good conversation. Functional is not really binary, right? There are functional programming languages. There are languages that use functional programming patterns. There are languages like C# that can use functional programming patterns but aren't really functional. What would you say is, like, the reference implementation? I
don't know if I would say there is a reference implementation, but I think it is important to talk about terminology, of course. And there are multiple approaches. A lot of them are, a lot of functional programmers or people that identify that way do come from some of the, the static type ecosystem. And there's a lot of great things over there. You were just talking about Swift, right? Interestingly, though, I see a number of people talking about some, especially when you're trying to apply these techniques across languages. I think there are some simpler stuff you can use to start with. And, by all means, explore all the routes available and find out what works for you in your problem domain and how you like to model problems. But I think you can, the big ones that come to my mind is stuff like using plain immutable data, rather than, like you said, a lot of stateful singleton object stuff like that, having data, and then in particular having immutable data that doesn't change out from under you, especially if you're using any sort of concurrency in your application. With a name like functional programming, it probably also makes sense to talk about functions. Now, I don't think you necessarily have to have, like, first-class functions, although you probably should, and not having them is kind of crazy in 2019. Thankfully, we do have them in languages like Java now, right? So that's nice. But I think you should also focus on idempotent functions, right? Modeling things as quote-unquote pure functions, where they're like mathematical functions, and the output, to what extent possible, and this is where you can get on a conversation, right? And like Haskell or Clojure, like, how far do you want to push that? Where do you call it practical and accept, little bits of state where you need them? Or, how functional do you really try to make things? But to the largest extent possible, kind of push state to the edges, isolate I/O, make it really clear when you're doing those sorts of things, and let everything else in your application be pure functions.
Yeah, I mean, I think one of the keys, right, is that anytime there's state or, mutability, it's a good sign that you're in the functional world if you're basically forced to be very intentional about those things, right? You can't have accidental state And maybe, Wes, just for a second, let's just dive into some of the problems you're going to avoid. For instance, side effects, right? You mentioned concurrency. That's a huge deal. Just thinking about asynchronous programming and concurrent programming is actually, and for me, and I'm wondering what you think about this, easier if I think about it in a functional paradigm. And frankly, the less state I have, the less concurrency hurts.
Yes, exactly. Right. I mean, you can get into situations where if you've modeled it nicely, then because it's a pure function, you know it doesn't affect anything outside of its scope. So you can just, if you need to, have it, give it more data and run it on more threads. Where does that come up for you? I mean, are these multi-threaded web applications that you're running, or separate Rails processes?
So a lot of what I do is actually I spin up microservices for some of these monolithic Rails apps that do like heavy data processing. Yeah.
Okay. Little helper services.
And those I really do try to keep them in F# and basically truly functional. I have one alive right now in Rust that's doing some interesting STL stuff. Granted, some of this is by virtue of it's literally running on not Lambda, Azure Functions.
Ah, yeah, sure.
Data in, data out. Right, there's no state. You get STL file in, we do a bunch of stuff to it, the result out. That helps me, if you know hosting Rails apps, you do want to avoid your process getting too big and taking too much memory and having issues.
Oh, man. Why is that such a problem? It's nearly every Rails app that I've had to support over the years, at one point or another, gets into that state, yeah.
Yeah, there are some, it's like GNOME, right? It's like the GNOME desktop. There were some decisions made long ago that leave it open to this problem. Part of it is Rails is doing a lot of magic for you, and that just takes memory.
So this is an interesting example. Maybe you can help me. I've been doing a little bit of Ruby. I've had some tools that I've been using that are Ruby libraries or work well in the Ruby ecosystem, and I'm familiar enough with it. It's not my best language or anything, but I know how to get stuff done. So it's been an interesting experiment to just try to do so in a functional manner where possible. But I do find myself often running into things that I think, I wish this API was modeled differently. So one of those examples was, I'm using the Mechanize gem.
Okay, yeah.
Which is it is a stateful thing. You get this like stateful web browsing agent that you can go, crawl and interface and submit forms and walk around web pages. And honestly, it makes it really easy. Like there's, if you just need to go automate something that doesn't have an API, it's a pretty helpful tool. There's similar libraries for other environments, but you get this like crazy, weird object. And anytime you have to deal with serialization or discoverability. Now, in static languages, it can be a lot better. You at least get some nice IntelliSense sort of stuff to try to help you. And,
yep.
Maybe if I had RubyMine open, it would do that too. It's just all these different objects have different APIs. And most of what I wanted out of it was data, right? Like I'm just trying to get like values out of these form fields. Why you give me this object? I just want a hash map.
I mean, what you've just hit is the fundamental criticism of Ruby, and usually people mean Rails. But is this actually a Rails project, or is this something separate?
There is some Rails, but most of these are a little smaller things on the side.
Yeah, I mean, Ruby. I like Ruby. I'm not going to dunk on Ruby. I have large systems written.
And there's plenty of stuff, like the blocks and map, and like there's all the primitives are there.
Well, so this is a thing. So newer versions of the language, it's actually a great contrast to C#. They do have it, right? Like you can do the MapReduce thing, which I think you're going to talk about in a little bit. It's like one of the core functional techniques, right, in Ruby. The problem is every gem, which for those who don't know, gems are basically Ruby libraries that you pull in, is probably written to be stateful in OO. So it's going to kick and scream every step of the way, just like what you're saying, Wes, where you just want a hash, right? You would just like a hash, or what I would call a hash dictionary, whatever, of that data.
Yeah, a key value store with other simple plain data underneath it.
By the way, calling hashes dictionaries is an Objective-C thing. Just throwing it out there. As I'm sure you know now.
Oh, you. I do. I have recently learned, it's not a bad term.
It's not a bad term. It's a fair term for it. But the problem is, yeah, you're right. I mean, personally, this is one of the more annoying things about the Ruby ecosystem to me is oftentimes, instead of just being able to get a hash of whatever it is, like you're using this Mechanized gem, you have to learn the API for that specific library, which there's a cognitive load there. A more functional first kind of environment, that wouldn't be the case, right?
Right. Yeah, and as you're surely discovering with Clojure, that very much has a data-driven sort of thing, where instead of statefully calling methods on an object to configure some library, you pass it some nested data structure that acts as the configuration for it.
I'm curious, what type of small Ruby apps are you actually writing? Like, are they web or are they like command line?
A little bit of both.
Okay, well, Mechanize is obviously web, but okay.
Mm-hmm. Yeah, a little bit from column A.
And how are you finding it when you try to apply a functional technique? Is it, or have you just given up on that?
I mean, I don't know that it would work super well if I had to interrupt with a lot of like regular Ruby developers. They'd probably be like, why are you doing it this way? But I think for the most part, I mean, I just, I try to, and I have some examples we could talk about. I just try to push my interactions with the, object-oriented or imperative stuff kind of to the edges. And I have a big bank of, pure functions to call on, and then probably some main thing somewhere that's going to go do some I/O or like call into the mechanized stuff to get the data out of it. And then from there, I can process the data in a series of maps and reduces and filters or, whatever. Maybe some loops just because it's, easy in Ruby.
Yeah, well, and you can also iterate over Ruby collections, right?
Yes, yeah. And so Ruby has lots of nice little primitives. And I find there's a slightly, I don't know, I don't really love either of it in Python or Ruby, trying to fudge it in like this. But I find myself frustrated less in Ruby, I think. Even though there's this, Rails-led reputation for magic, like every time in Python when I try to like append to a list or an array or whatever, and it mutates it, I always get so confused. And in Ruby, I find myself, I don't know, it just feels a little more intuitive for the way that I want to work. And it's a little more like working with like proper immutable stuff.
I could see that.
So it's not been too bad. I think mostly it's just that like the culture isn't there.
Oh no, the culture, I mean, again, the biggest library is Rails.
So I thought maybe we could talk a little bit. I have a resource that I think it's a great talk that I recently found. It was from a Clojure conference, but I think it's totally applicable to people just trying to program or explore programming in more functional ways. And that is a talk called Solving Problems the Clojure Way by Rafal Ditwald. I have just 3 clips here I thought we could go through. And the first one kind of talks a little bit about, like, we do live in an object-oriented world, and we just kind of have to accept that.
And the OOP approach has worked quite well. I mean, the industry basically, like, if you think about it, the industry has been dominated by object-oriented programming to the point where, JavaScript added this way of doing things. But it's not without its detractors, and it's not without its problems. I'm not going to go into in depth what the problems with object-oriented programming are, other than to just say that functional programming does have a completely different set of answers to a similar problem. So when with object-oriented programming, they said let's organize state, use objects, and think of programs as interacting agents. Functional programming instead agrees state is confusing, but says let's avoid it. Let's just say state is bad. And when I say state, I mean any values that change in place. So if you have an array and you want to increment it in an imperative programming language, you just increment that array. And in functional programming, we'd say, you know what, no, that's bad. Because then when this array is being passed to some function and that function changes it and we didn't expect that, things go wrong. Like basically state is the root of all problems. So let's try to avoid it. Now, compared to classical imperative programming, and functional programming languages also gave us a new tool, and that was the function. And that's to distinguish, and we use the word function to really distinguish from the idea of a procedure. And the main difference between a function and a procedure is that a procedure, you can declare, you have to give it a name, and you can still pass procedures around maybe by name. You can pass the names of procedures around, but you can't pass a given function that you create dynamically as a value, whereas with functions you can. So procedures can't really be passed around by value, and you can't create them on the fly and pass them around, whereas with functions you can. Now if you've worked with JavaScript, anonymous functions, they're everywhere, and so it's not that crazy of a concept. But at the time, it was definitely something very different. And if you work in a strict object-oriented programming language, they don't really have these functions that you can just pass around. Sometimes they're also called lambdas, but they don't have them. Like Java only recently, had made it possible to pass around functions on their own, and barely anyone uses that because, why do you need functions? You just have methods on objects. But in functional programming, we say, no, we don't need an object. You can just have a function. It can just sit on its own. And the mental model of functional programming isn't steps to achieve some solution, isn't interacting agents working with each other. It's really mostly thinking of a program as a pipeline of input to output. We think of, okay, what is the data that our program is going to be receiving over time, and how do we transform that data into the outputs that we want?
I'm curious if you agree, Mr. Dominic, because that is what I find more and more when I can think of things as a transformation of a pipeline. It's just easy to think about. Now, not always, not everything can be modeled that way, but it kind of takes these techniques to an architectural level, because when you look at a pipeline, you can introspect and, you can place logging or metrics easily between all the values, and you can isolate individual pieces of the pipeline to only have to reason about a chunk of it.
Yeah, I haven't thought about that metaphor before, but I like it. Top of my head, I think it's pretty good. I tend to think of it as almost a flow, but I guess it's really kind of the same thing, right? Like a stream flow, literal streams. I worry about any of these analogies or abstractions, or kind of just like, metaphors is the right word. Because don't they start to fall apart eventually?
Yeah, sure, right? I mean, all abstractions are leaky, as they say. So there is limited value, and you should be aware, yeah, of course, right? I mean, mostly we're talking about higher level ways to think about the problem, and then you might end up having to do something right on the outside, or sealed away in some implementation detail where, like it gets a little grisly under the hood, but you're saved from having to deal with that, and you're presented with a nice, clean interface. Clojure has a data structure or a nice little thing called transients. So most of the stuff you're working with are immutable trees, basically. Transients let you turn those into mutable stuff, and in a closed context, make a bunch of changes to them in a faster way, right? Suddenly you've got the superpower, you can mutate things, and then at the end of that transaction, it's sealed all up, and you're just presented with an immutable interface again. So, it gives you a little escape hatch where if you need to, you can get some extra speed inside some fast little function in a loop somewhere, but for everyone else, it just looks like a regular, nice, immutable value.
Yeah, I can't disagree with any of that.
Well, then here, let's see what you think of this.
Now, you might be thinking, well, we want to avoid state, but mutable state and side effects are inescapable. That's kind of almost the point of programming. We want our programs to do something, have some side effect. If all our program did was just make our laptop hotter and then contribute to the heat of death of the universe, it wouldn't really be useful. I mean, unless you're cold. But the purpose of programs is to do something, even if at the least it's to print out a single number. If all we want to do is take in a bunch of inputs and print out a number, that's still some side effect. It's printing to the console. But there's typically, real programs have other side effects that we think about, and it's things like, communicating to a database and changing things in a database, sending an email or triggering some other external API, making an HTTP request to another server, or writing to the file system. These are all kind of effects that a program, typically what we would want a program to have on other parts of your computer system. So functional programming would say, okay, yes, we do want side effects. And so it's not saying let's get rid of all state, let's get rid of all kind of side effects. Functional programming is saying, but let's just do our best to avoid it. And how? How do we avoid it? So how do we avoid mutable state, so values that can change? How do we avoid actually mutating that state in our programs? And how do we avoid all these other kinds of side effects? We kind of have functional programming has like three techniques, three little tricks that you can use. And those are minimizing, concentrating, and deferring. So minimizing is just trying to have less state, so less values that we're keeping around. Concentrating is saying, okay, well, if we have to have values, let's keep them all in one place rather than throughout the program. And deferring, well, we'll get to deferring in a moment. And this minimize, concentrate, defer also applies to mutations. So with mutations, we're saying, okay, let's try to have as little parts of our code that actually change values in places, so places that change state. And if we do have to have mutations, let's keep them as much together rather than spread throughout the program. And similarly with side effects. Let's try to decrease the amount of places that we do side effects, concentrate the places that we do side effects, and if possible, defer them either to kind of the last step in our program or to a completely separate system. Right? If you think about like a database, you're not dealing with necessarily doing all this fancy work that the database needs to do in order to keep track of the state and do a query and whatever. Presumably there's a whole bunch of state that is necessary. From your point of view of using a database, it's just like, here's a command. You figure it out.
And databases are something we're all kind of familiar with, right? I mean, SQL is a sort of classic declarative API. Now, it gets hairy, especially when you're trying to optimize, complicated queries, I'll admit. But at least on the surface, the idea is you just sort of say, like, hey, here's the shape of the thing I want. Go get it for me, and I don't need to reason about how you're going to do that. I'm wondering what you think, Mike, of the, some of his principles there. Minimize, concentrate, defer. Have you used those techniques yourself?
Yeah, that's exactly what I think we both mean here, right? It's your function should only do one thing, not things plural, one thing.
One things.
Because saying things completely cuts the knees out from you, my point there, right? With no side effects, you should minimize state. Obviously, yeah, you're going to hit cases where, you just need state. It should be pushed off. I actually like your metaphor that as I was thinking about it, as I was listening to that, of pushing it off to the side. State should only come when you actually need it, not everywhere. I think the key here is that it's viewing your entire architecture just as data flows in to a function, it flows out, and then probably into another function. I think I'm actually a little harder on you on one point, though, Wes. I do think functions have to be first-class objects, for lack of a better word, for you to really be functional.
You're probably right there, and I'll say I certainly prefer it in a language. Now, one thing you listener out there may be thinking is some of this stuff kind of sounds like all the, the React hotness in the browser and this sort of, views on top of data and one-way data flows, reactivity, that sort of stuff. Mike, as you explore Clojure, you might come across, that the Clojure script community, they love React. There's a popular sort of larger framework that is kind of similar to Redux, although older, called Reframe.
Okay.
And there's a great little example in this talk about a change Reframe made that I think is a perfect example of these principles.
So I mentioned Reframe, which is the kind of Redux equivalent. It's this library that helps manage state in a front-end application. And there's also a very interesting example in a change that happened in Reframe. So originally, in one of the first, in the first 1 or 2 years of Reframe's existence, you'd have some code, like here, it's Clojure code, so you can be happy we're at a Clojure conference, so you can see some Clojure code. And this is a code to register an event handler. So something, a state transition, something that you click a button and you want to trigger something to happen, you'd register one of these things to handle that. And so this is adding product to a cart. And in this situation, when the user clicks that button and triggers this event, we want to do 3 things. We want to make an AJAX call to tell the server, oh, hey, this person added this product to their cart. We might want to dispatch, so trigger some other event to happen. And we want to update our local global state object, which in this case is called DB, to indicate that that item has been added to cart. So this seemed fine, but the Reframe folks are, pretty happy about functional programming, and they saw this and they thought, you know what, this isn't functional enough. This could be done better, because here we have 3 side effects, 3 things that this function is doing that is triggering side effects in the rest of our system. Could we do better? And you might think, well, no, but you know what? The whole point of this is to have side effects. But check this out. They eventually came up with a new idea. They said, instead of actually calling other side effectful functions in your code, like making an AJAX request or triggering another event or updating the database. Well, actually, in this case, updating the database, this doesn't cause a side effect. This just returns a new database. So it's these two that are the problem, AJAX and dispatch. Let's instead write our functions so that they just return an object that says what I would like to be done. So I would like, if calling this event, for an AJAX event to happen with the following information. I would like for this other event to be dispatched. And I would like for the database to now look like this. But it doesn't actually do it. This function itself doesn't do those things. It just says, here is what I want to be done. So it's just like declares, these are the things I want to be done, whereas on the left-hand side, it actually does them. And then the reframe system, other parts of the system actually take this and do something with it. This is another example of deferring. Instead of having a whole bunch of these events that actually have side effects and do things, we have these functions just declare what they want done, and we have one part of the system. It's a complicated part of the system. It has to figure out how to do all these things, do all these side effects, but at least it's all concentrated in one place, and the rest of our application is pure and easy to understand and easy to test. Like if I had to test this, I'd have to test, okay, is the AJAX event actually happening? So maybe I have to like mock an AJAX thing or actually just, do an integration test. Whereas on this side, I just have to check if the thing that it's spitting out is the thing that I wanted. This is usually kind of trivial, but you can imagine that there might be some complicated stuff that's going on in here, and all you have to do is check, is it doing that complicated stuff? And then let's hope that the person that implemented, or if you implemented the thing that does the AJAX bit, it just has to figure out how to do that, and so you can test those things completely separately. So again, kind of another one of these example of doing things functionally.
And I just love that example because it makes me immediately think of what I was talking about with Mechanize, right? Like, all right, at some point, yes, there's no escaping, maybe mocks, but certainly integration tests. Like if you're going to scrape a website, there's a real website out there and you're going to have to, it could change. There's no replacing actual tests for that thing. But if I can move a lot of that stuff and just have a bunch in the middle that's using pure data that I'm manipulating, I can stop having to deal with all this mocking stuff and I can just write easy tests.
No, that's obviously one of the core advantages, right? I think, particularly we mentioned Ruby before. Mocking state or creating mock state is probably the better way to phrase that, is a huge thing that Rails developers do that takes a lot of energy and time. I'm not going to come out and be against, mocking frameworks. But yeah, not having to do that, right? Not having to create this entire infrastructure that is basically, aping what real state might look like. It's a big deal.
Yeah, exactly. And, it's easy too. If you do want to say you're running some of these tests, a topic for another show is generative testing. And if a lot of your inputs and outputs are data, well, it's really easy to do that too, because you can generate data in a way that might be a little easier than having to make objects and keep track of them and interact with them all over the place. I'm curious if do you have any go-to libraries? Do you have any tricks that you've had to do? Something I've observed is it can sometimes be easier to teach people who are new to programming to start with some of the functional stuff, because coming from an imperative language or approach, you kind of have to unlearn some things.
You have to unlearn some things, and it's not necessarily intuitive. One of the primary challenges using a lot of F# is that a good, very large percentage of the the .NET libraries, the NuGet packages you're probably going to want to use are assuming that you're in a C# 00 type of pattern environment.
Yeah, and so interestingly, you're kind of in a similar place. Clojure finds itself with Java is, having system languages and paradigms to interact with, even though you live in your own world. And I'm curious, do you kind of find yourself making functional wrappers or just going with bare interopt?
You end up writing thin functional layers. I cannot claim, that I've never just in a rush having to ship, just pulled something in and that is one of the strengths and weaknesses of the particular case of F# is that you can always drop back to the more OO way of life if you need to.
And I think that can be important, especially as you're learning and in real life scenarios. It can be super useful to have an isolated learning environment, right? Go learn SML or Scheme or something. It's also, nice to have escape hatches and easy ways to kind of fall back where you need to, because sometimes you just need to finish the darn thing, even if you're really enjoying learning. Sometimes that takes a while and you're a little slower.
It all takes time.
Ain't that the truth? Well, I'm going to have a bunch of links in the show notes. So the architect of Clojure, Rich Hickey, he's a big Java developer. He's given some good talks at Java communities, and he's just a great speaker in general. So I'm going to have multiple links to several of my favorite of his talks. In particular, I would really point everyone at the value of values, because it doesn't have anything to do with Clojure, really. For me, making the shift and thinking from stateful object or even thinking of a dictionary as an object, and instead thinking of that as a value, thinking of it more like a number or a string and not as some mutable instance. That's huge. And it has major design decisions, but it takes a while to percolate and really enmesh with the way that you're thinking about programs. Go watch the value of values. Do you have anything that's been helpful in your journey, or you want to point people to, Mr. Dominic?
I would really just suggest, if you're working primarily in one of these more, like a Java, C#, and all of this sounds a little intimidating, one, definitely take a look at the resources here in the notes. But also, you don't have to start by just like taking the C# example. You don't have to start by, creating a file in F# and trying to do an entire feature in it, right? You can start looking at either doing some type of MapReduce, or even just avoiding state and mutability as much as you can in C# using some of the Lambda functions. I think you'll find it helps, even if you're not, even if Wes and I haven't convinced you that this is something you really ought to do, right? I think there will be value there. You don't have to go all the way, is what I'm saying.
Yeah, absolutely. Just adopting a few of the techniques, thinking about things, modeling them as more pure functions. Honestly, even if you don't change anything, I think it's just useful to be aware of that, because there's tons of places that little stateful habits and techniques creep in. And if you're not careful, you'll totally miss them.
Well, it's like doing a little Objective-C. It's just important as your development as a engineer.
Yeah, exactly. It broaden your horizons. Now, Mike, you've been hard at work doing that. So here's a reminder to everyone out there. This was a pre-recorded episode, but we will be live next week. Yes, that's right. And Mike is going to be checking in on his journeys with Clojure. I'm looking forward to it, and I'm sure we'll be talking a little bit more about functional programming. Mr. Dominic, if they just can't wait, I'm sure you'll be heckling me or just yelling into the void on Twitter. What's your handle?
It's @Dumanuka.
I'm there too. I'm @Wes Payne, and you can find the whole network at Jupiter Broadcasting. If that's not enough, well, head on over to jupiterbroadcasting.com, where you can find all the other fine Jupiter Broadcasting productions and find the calendar to find out when we're here live. We're doing more live shows these days. It's way more fun when you show up, so we'd love to see you. That's it for this episode. See you next week.